this, but once the proposal get approved, I'll order everything ready to be.
Yeah.
But I had a question about something we did last class. You only wait till you begin class after or after class?
Well, class should start now because it's 10 o'clock. Good morning to everybody else. Ask your question, please. Mr. Buchan?
Yes. My question was what we did last week with the delay. I was confused and how you was getting the delay.
What do you mean? What do you mean how we did the delay? What does that mean?
All right, you see when we used
Oh, exactly. Let me get my notes from last class. What page you on?
I don't already write my notes in the book, so I don't really have to. But it's the one with the entry would be to the power n u of n.
That is really vague.
I'll get a page up with you right now. Let me look at the pictures. One is on page 9.
Page 9. Yeah, what about it?
Yeah, I see how you got the z to the -2, but I didn't know what process that you did to actually achieve that.
I just use the law of indices. I just still use high school algebra.
Because I see it was z to the -1 over z plus 0.25.
Yeah, what about it?
But after the next step, you got z's to the -2. I didn't really understand.
Okay. You are asking me how I go from here to how I go from here. That's what you're asking me. You're asking me how I go from here to how I go from here.
Yeah.
Oh. You asking me how you go from 0 to -1 to this? That's what you're asking me. Isn't it obvious? Isn't it obvious that the numerator on the right-hand side is equal to the numerator on the left-hand side? Mr. Buchan?
Yeah, looking at it right now. Yeah, it's the same.
So I don't understand your question then.
Yeah, I wasn't seeing it clearly.
Anything else?
No, that's it.
Okay. I'm still missing one person. All right, Tori again. I wonder why he's always late. Recently. All right. We must continue on. Okay. That was last class. That was a question from last class. Okay. We want to get partial fraction z inverses from partial fraction expansions. And this is a review again. This is review from 320. Suppose y of z okay. This is not an entry in the book, but we recognize this as a proper quadratic. Okay. So this could be written as a over z plus 0.25 plus b over z minus 1. What is a equal to? What is a equal to?
That should be z over z minus 1. And we can let z equal that should be z should be equal negative 0.25.
Yes. Yes. Point 2. Okay. To get a, we cover up that and we left with z over z minus 1. And then we put in the value of the root of what's what's dividing a. So what's b? What's b equal to?
Would that be z over z plus 0.25?
Yes.
When z equals 1.
Z equals 1, yes. So that's 1 over 1.25. That's 0.8. Okay. Any questions about that? So this becomes 0.2 over z plus 0.25 plus 0.8 over z minus 1. Okay, I'm going to a new slide. Okay. So how do I find the inverse z of these two? What do I need? I see nobody's been practicing.
The entry on the table I see that we should use is B to the N, U to the N. You see?
Tell me what the z transform is
Z,
on the entry on the table.
Z over Z minus B.
So this should be z. That should be z there. But to put the z there, we got to put the z minus 1 there. Otherwise, we changed it. Same is true of the second one. We need z here. But to put the z there, we got to put the z minus 1 there. Okay. So y of n then, y of n equals inverse z. Okay. Okay. And then from the table, this is the entry in the table. And that's minus 0.25 to the power of n u of n. But this here says you got to delay by 1. You got to delay by 1. And then again from the table, this is 0.8 u of n. But this here says you got to delay by 1. Any questions about that? Okay. I hear no questions. Let's do another example. Oh, sorry. I forgot the 0.2. That's 0.2.
So for the end, then you didn't have to do the same thing over again. Like, you see?
Excuse me?
No, I'm looking at the
last
second.
one. What
The
is the
last.
expression saying?
Listen, somebody's talking. Please be quiet until they're finished. Mr. Buchan, please go ahead.
No, I was asking, you see, for the first part of the term, I thought we would have to do the same thing for the second part of it. Like you always say,
I don't understand what your question is.
all right, you see how we have 0.2, open bracket, negative 0.25, close bracket, enter the minus 1, u of n minus 1.
Yes.
I thought we would have to do the same thing for the second part, but that's not correct.
I don't understand what you mean we do the same thing. We are doing the same thing from my point of view. I don't understand what you mean by do the same thing. You have to do the entry in the table. The entry in the table, I don't know why this is difficult to follow. This is the same thing we did with Laplace transforms. The entry in table is this. That's the entry in table. That gives us this.
Mm-hmm.
The point two as well. The point two as well. Except that it's n. It's not n minus 1. This plot here tells you you have to make it n minus 1. The entry in table is this. That gives us this, but not n minus 1, n. This tells us we have to make it n minus 1. So I am doing the same thing, so I don't understand what you mean by I do the same thing.
No, I was looking at it different. Sorry about that. I see now that there's 2 different entries.
Okay. Anybody else? Who was somebody else was trying to make a comment?
Oh, that was
You could
me,
go.
Scatter.
And what were you saying?
Oh, I see you didn't write the beta.
What does that mean? I didn't write. Oh, what do you mean? I didn't write the beta. What does that mean?
1 to the power of n minus 1. How in the first expression you had the 0.25, and the second one you didn't say. You didn't write the 1.
That's 2 different entries. That's the mistake I almost made. So the second term, the entry is U of n.
Folks, you must learn the table.
Oh.
I cannot help you if you don't learn the table. You will always be confused in class if you don't learn the table. There is no 1 to the power of n for the second entry. There is no 1 to the power of n. There's U of n. That's it. And 1 to the n, by the way, is just 1. Any other questions? What do we do with this one? What do we do with that one?
Would that be A over Z open bracket Z minus 1 plus B over open bracket Z minus 0.6?
You don't see 3 factors?
So 1 would have to be C, right?
You'll have to have a C. This is A over Z plus B over Z minus 1 plus C over Z minus 0.6. Now, what's A going to be? What's A going to be?
A will be 0.5 over Z minus 1. And the next bracket will be open bracket Z minus 0.6.
Yes? That's it?
No, and he'll make Z equal
C equals what? 0?
0.
0. So this is 0.5 divided by -1 times -0.6, which is 0.5 divided by 0.6. It's 0.8333. Send me what B is in chat, please. Send me what B is in chat. Just the answer. Not the working, just the answer. Yes, Mr. Beauchamp, that's right. Yes, Mr. Johnson, that's right. That's it? Nobody else?
Hold on, I can send it right now. Sorry, on my phone.
No, Mr. Roll, that's not right. Nobody else? Okay. Rest of you, please follow. So B is and Z is evaluated at 1.
You thought there was a 3 at the end?
Excuse me?
I thought the Z was a 3. Sorry.
I don't know what you're talking about. What Z
I
you
thought
talking about?
the one outside the bracket in the denominator. I thought that was a 3, not a Z. Sorry.
Then why did I write A over Z? Why would, if that was a 3, why would I have written A over 3? That would not have made any sense. So this is 5 over 4 equals 1.25. Any questions about this? For those of you who didn't answer, any question about this? You get another chance. Send me C, please, in chat.
Dr. Godric,
Yes.
um, I probably missed it, but could you explain how you got the 0.4 one more time, please?
0.4? What are you talking about?
We have 0.5 over 1 bracket 0.4.
1 minus 0.6?
No, I talking about where you have 0.5 over 1 bracket 0.4.
You asking me where I got 0.4 from? Isn't that what you asked me?
Yes, sir.
I am substituting Z equals 1 into this. Z equals 1. If you put Z equals 1 into that, what do you get?
Right, John Fuller. Sit. Hold on, sir.
Was that Mr. Kerr? Mr. Kerr, you got your answer?
I looking at it. Give me one second.
You what? You what?
I said I'm looking at it, trying to figure it out.
I'm just asking you to put Z equals 1 into this first equation. Put Z equals 1 into that, and what do you get?
You already write it out for you, you know. You put
Excuse
the
me?
substitute. I say you already write it out. You already have it done with
Yeah, but
0.5.
he's asking about the 0.4. He was wondering where the 0.4 comes from. And if you
Well,
would just substitute 1 into this equation, you'll see it right
1
away.
minus
What?
0.6.
Okay.
1 minus 0.6 times 1.
Yeah, okay, I got you now. My bad.
All right, C, please. Let me see. So, Mr. Johnson, you're right. Mr. Anderson, what your answer's not right, Mr. Anderson. Mr. Johnson, your answer's right. Mr.
Right.
Buchap, your answer is right. And Mr. Roll, your answer is right. All right, so please, let's do it. Everybody pay attention, please. So C is going to be 0.5 divided by D divided by z minus 1, evaluated as z equals 0.6. So it's 0.5 divided by 0.6, okay, minus 0.4. Equals 0.5 divided by negative 0.24 equals negative 2.083. Any questions about that? So y over z
Lord Godred, I have a question. You
Yes,
see
go
for
ahead.
z, when z equals 0.6, why we use 0.6 in that situation instead of 1?
Why you think you're supposed to use 1?
We use 1 for the first one because z was equal to 1.
Why was z equal to 1?
Let me look at the past page. Yeah,
You all,
I don't follow with that piece though.
exactly. You don't know the rule. All right. I can't see my screen for some reason. There's a big black square in the middle of it. Are y'all seeing that?
No, sir.
No,
All
sir.
right. So I'm going to have to probably get out of, I don't know if that's Zoom costs or that. I may have to get out of Zoom to get rid of that. So be prepared to sign back on if necessary. Or I may just have to get out. Let me try getting out my document camera first. Maybe that's it. Okay. All right. I got rid of it. It was my document camera. Okay. So y'all seeing my my writing pad?
I just see a black screen with your name on it. Now I'd come back up.
Okay. All right, Mr. Anderson, I think you had a question. Go
Yes,
back
sir.
here. All right, let's go back here. So your question is, how do we know what to evaluate at? Okay, so let's look at this expansion. You see A? A is over Z. What's the root of Z? What's the root of Z, Mr. Anderson?
That'll be 3. And
It'd be what?
oh no, sorry. I thought it was over here. The root of z would be 1, eh?
The root of z is 0.
Oh, sorry.
Z equals 0. The denominator equals 0. That's what I meant. Well, that's what I mean by root of. You set the denominator 0. Z equals 0 means z equals 0. You set the root of z negative 1. That's where you get 1 from. You set z equals z negative 0.6 equals 0. That's where you get the 0.6 from. Okay. So you use you use 0 for A, 1 for B, 0.6 for C. You follow?
Yeah, yes, I follow.
All right. So that's why when you're calculating, when you're calculating C,
Oh, and then, yeah, that's where the 0.6 come from. All right, I
Yeah.
understand that, guy.
okay, alrighty, good. All right, so this is equal to,
Also, another question: if we was looking for A, Z would be 0, right?
yes, that's what we
All
have.
right,
See
I
here, that's
got
what
you.
we have. Look on the screen. A, Z equals 0.
All right, I got you. Doc got it.
Alrighty.
Yeah, that Z almost looked like a 3, but okay.
We are not dealing with 3s, we're dealing with Z's. So I don't know why you have the confusion.
Yes, sir.
3 is a constant, Z is a variable. All right. Send me in chat then an inverse Z of what I have circled in red. What's the inverse Z of that? Mr. Rule, the inverse z will not have a z in it. There are no z's in the time domain. If you take the inverse z, you're going back to the time domain. Well, in the n domain. Mr. Johnson, I'm not asking for the inverse of z.
You asking for the
Oh.
front?
I'm asking for the inverse z of that what I have in circle in red. The inverse z transform. I'm not asking for the inverse of z.
Yeah, I did solve for that.
Excuse me?
I did solve for the 0.833 over z.
But you didn't give me. Well, where's the 0.833 in your answer? Where's that?
Let me
You-
try again.
Thank you. All right, again. Okay, let me see. Mr. Johnson, you're making it up as you go along. That's not right at all. Please pay attention. Since yes, please pay attention. If you look in the table, this is what you have. That's what you have in the table. What's the inverse z of this? What's the inverse z of 0.8333?
Wouldn't that be 1?
1? 1 is the inverse z of 0.8333? What's the inverse z of 0.8333?
But the only thing I can think of is 0.833 delta of n.
Yes. Yes. What function gives you a z of 0.833? Delta of n. 0.8333 delta of n. But what's the 1 over z? 1 over z is the same thing as z to negative 1. So this gives us this, but the z to negative 1 says make it negative 1. Any questions about that? Again, that comes from a knowledge of the table. What do we have to do with this? The second term I just circled in green.
You'll have to get a z in the numerator.
To get a z in the numerator, what do I have to do?
Multiply by c to the negative 1.
Yeah, so it's z to negative 1 z. So what does that give us?
That gives us 1.25. See 1.25 u to the n minus 1.
1.25 u to the n minus 1. S.
And the next one is the beta 1.
Z. This would be z to the negative 1. So the next one is negative 2.083. And then what?
Open bracket 0.6 n minus 1 to the n minus 1. U of n minus 1.
Yes, that's it. Any questions about that? All right, I hear no questions, so I'm moving on. Okay, here's we did this before. Now I'm going to do it another way. So h of n then negative 0.25 n minus 3 u of n minus 3. We did that before. Let me see what example that was. Example 2.1, I think.
I remember getting that n minus 3 though. Wait a second. No, you're right. You're right. Because I just multiply through by z. Z to the top, z here, and then that z to the negative 1 disappears. Okay, so n minus 2. Thank you, Mr. Buchamp. Give me a second. Yeah, that's right. That's what we got. Okay. Now let's do another way today. Multiply top and bottom by z squared. Put it in standard form. So the top becomes 1. That's z squared. That's 0.25 z. Everybody see that? This is just a standard form of that. By multiplying top and bottom by z squared. So this here is so now I can use partial fractions. So a questions about that? Okay. So this, we just found, so h of n then, okay, is the inverse z of 4 over z minus 4 over z plus 0.25. Okay. And we discussed this. The first one is 4 delta n minus 1. The second one is z negative 1. That would be minus negative 0.25 to the power of n, but it says n minus 1, u of n minus 1. And there's our equation 1. There's our equation 2. And I can assure you equation 1 equals equation 2, even though it doesn't look like it.
You didn't forget the 4, right? To the top? No, wait.
Oh, the 4 here, yes. In my mind, I put the 4 out, so let's put the 4 back there. Thank you. Okay, and I can show you these two are the same. As a matter of fact, let's calculate both of them. Let's do n equation 1, equation 2. N equals 0, n equals 1, n equals 2, n equals 3. All right, so for equation 1, we have negative 0.25 to the power, this is by n equals 0, to the negative 2, u of negative 2. Right on the bat, you know that's 0, because of u of negative 2. So that's 0. Equation 2. Equation 2 is 4 delta 0 minus 1 minus 4 negative 0.25 to the power of negative 1 u of negative 1. Delta of negative 1 is 0. U of negative 1 is 0. So both of these give 0. So n equals 1 gives us negative 0.25 to the power of negative 1 u of negative 1. Again, that's 0. That's 0. Equation 2. Equation 2 is 4 delta of 0 minus 0.25 to the power of negative 1 u of 0. Okay. Let's not forget the 4 there. Zero, sorry. N equals 1, this is 0. Okay. So this is 4 times 1 minus 4 times 1 equals 0. And then the last one I'm going to do is 2. So equation 1 is 0.25 to the power of 0, u of 0, and that's 1. And then we have 4 delta of 2, delta of 1, sorry, minus 4, negative 0.25 to the power of 1, u of 1. So this is negative 4 times negative 4, negative 0.25. That's 1. That's 1. Yeah, so even though those two equations look totally different, they are in fact the same, and that can happen in digital circuits, in digital signal processing. So depending how we choose to find the inverse z, we end up what looks like different answers, but they are in fact the same answer. Okay. Okay, let's do another example. What's the first step?
Multiply top and bottom by z squared.
Okay. Now what?
Now you have to, that look like a not strictly proper.
So what do you do?
You divide, you use long division.
It's a minus sign here. So this is minus 0.1 z. This is plus 3. So this here is 1 plus minus 0.1 z plus 0.3 over z squared plus 1 z minus 0.3
Now what?
Now you have to use partial fraction expansion.
Not yet.
Not yet? Let me see.
How we know what the roots are?
You call it roots or you call it poles? Yeah, poles.
Well, same thing. If you know the roots of the bottom, then those are poles. How you know what the poles are?
We have to solve it, the quadratic equation.
We have to solve the quadratic equation to find the roots. So z squared plus 1z minus 0.3 equals 0. So z equals what? What is z equal to?
I get z equal to half and negative 0.6.
Where you got that from?
Let me make sure I write it right. Hold on.
You don't know the quadratic formula? Is that what you're telling me?
B plus minus the square root of.
I don't want to hear. I don't want to hear you parrot the quadratic formula. I want you to apply the quadratic formula. Mr. Johnson, you was just telling me what the quadratic formula is equal to. Now apply it.
Yes, sir.
Apply it aloud, Mr. Johnson.
You mean say so 0.1 plus minus.
It's negative 0.1. It's negative b. It's negative b. It's not positive b. It's negative b. B is 0.1. So it's negative 0.1, yes? Plus or minus? Plus or minus what?
The square root. Make sure square root in the numerator. Negative 0.1 squared
Which is the same thing as 0.1 squared, yes?
plus 4 times 1 times
Minus 4. Why is it you don't know the quadratic formula properly? Minus 4 times a, which is 1, times c, which is negative 3. Negative 0.3 over 2 times a. So z equals negative 0.4 plus or minus the square root of 0.01 plus 1.2 over 2. This negative 0.1 plus or minus the square root of 1.21, which is 1.1 over 2. This 0.5 or negative 0.6.
So Dr. Carter, now what I said?
What did you say?
I said z equal a half and negative 0.6.
It is not a half of negative 1.06. The answer is negative 0.6. Miss Buchamp?
Yeah, that's what I was meaning.
Yeah, but that ain't what you said. It's negative 1.2 divided by 2, which is negative 0.6. Okay. Therefore, y of z equals 1 plus negative 0.1 z plus 0.3 over z plus 0.5, z minus 0.5, z plus 0.6. Which of course is 1 plus a over z minus 0.5 plus b over z plus 0.6. Send me in chat the value of a, please. Yes, Mr. Johnson, that's right. That's not right, Mr. Beauchamp.
Dr. Conrad,
Yes,
you said to send the answer for A?
yes. No, Mr. Stewart, that's not right at all. All right, let's do it. Only one person got it. I see where Mr. Buchat went wrong. The thing is, we don't look at the one at all. Okay. Back here, back here. The one remains the one. All right. It's this. It is this that is equal to this. So you're not working with the one at all. So A is, you cover the 0.5, V plus 0.6, and Z equals 0.5. Oh no, that's wrong. The numerator is wrong. Five, 1.1. 0.2273. And similarly, B is Any questions about that? The y of z then is 1 plus 0.2273 divided by z minus 0.5 minus 0.3273 over z plus 0.6. And of course, we're going to need a z here. So z negative 1 goes front. A z here. Z negative 1 goes front. Yeah. So y of n, delta of n, inverse z of 1 is delta of n. And we have a plus 0.2273 times 0.5. Okay, the power of n, but it's n minus 1 because of z negative 1. U of n minus 1 minus 0.3273 minus 0.6 to the power of n plus n minus 1, U of n minus 1. Any questions about that?
Dr. Crowley, this is possible for me to see page 6. Got it, thank you.
Any questions about that? Okay. What's the first step?
Find the roots.
Yes. How are we going to do that? How are we going to find the roots of this? Stop share for a second. I'm going to open up Octave.
I know I get the same answers as the first one, but I just got 1.
You got what?
I got the same 0.5, the negative 0.6, and 1.
And how you do that?
My calculator does it.
Ah, okay, good for you. Can you see my screen? Can you see my Octave screen?
Yes, sir.
All right. So we need the roots of that cubic equation. We simply say roots. Roots of the polynomial. What's a polynomial? Okay. Square brackets, I think I need. Okay. 1, negative 0.9, negative 0.4, and then 0.3. Close square brackets, close other brackets. And there are the roots right there. Just like Mr. Beauchamp said. So if you don't have a fancy calculator like Mr. Beauchamp, you can use Octave. Is there a formula for roots of a cubic?
It'd have to be.
They have to be, really? Why there must be? There is, but there doesn't have to be. Is there, excuse me?
Nice how else would we solve it if it wasn't a formula?
Okay, would it be strange to learn that there's no formula for a quartic? Not a quartic, sorry, for a quintic? For polynomial greater in order than 4, there is no formula.
Why you want to invent one?
And somebody proved that you could not. A mathematician called Abel, I think it was. I think it's Abel or Bell, something like that, proved that there could be no formula, no general formula for a polynomial greater than 4. So then you ask, well, how do they find the roots? For 5th order, how do they find the roots? And the answer is there are numerical techniques. If you want to learn those techniques, you could do a numerical methods math course. But your calculator and Octave and all programs are using numerical techniques to find the roots. Anyway, back to this. This becomes 1. You're seeing my writing pad now, right?
Yes, sir.
Yes, sir.
Okay. 1 plus 0.9 z squared plus 0.4 z minus 0.3 over z minus root. So that's minus negative 0.6. That's 0.6. Z minus 0.5 and z minus 1. And then this part becomes, that part there becomes a over z plus 0.6 plus b over z minus 0.5 plus c with c minus 1. And you find a, b, and c in a normal fashion. Okay. Any questions or concerns? Again, let me say, if you don't practice this, you will not learn this. It's as simple as that. And it's clear to me, some of you all didn't practice Laplace transforms, because what we're doing right now is just like Laplace transforms. Partial fraction expansion, you did that in 320. You even do that in Math 270. And yet I'm still having people who don't know how to do partial fraction expansions. Students think they don't have to learn the material that's given them. Anyway, you can think what you want in life. There are consequences though. Before I say goodbye, any last comments or questions? Well, have a good day.
You do, Dr. Cartwright.